This is the Start the Session video for 05a-Debugging-m3, module M3. In that module, and so I'm bringing it up here and bringing up the instructions, I'm also going to minimize the part to the left here using that. If you ever see that goes away, that thing on there, look for the little symbol that brings it back and there again. So these ones are broken functions. There's just one in this case, just like the previous modules. But this time, the problem is not that the code breaks, but rather that it gives the wrong answer, simply the wrong answer. Now that involves a different kind of debugging, and so I'm going to illustrate that in this project here. So it says that isPrime is implemented correctly, so you can assume that. It says that the test cases are implemented correctly, so you can assume that. But here is the code for broken 1 that apparently has something wrong with it. It says that what comes in is a positive integer m that's at least 2. By the way, I don't write if m is greater than or equal to 2 in the code. When this is part of the spec, then you assume that m is at least 2, and it's the caller's responsibility to maintain that assumption. It would be wrong for your function to also check it, because that would be inefficient. What goes out is the number of prime numbers between m and 2m plus 1. For example, always look at an example. Always look at an example. If m is 3, this function returns 3, it says, since there are 3 primes between 3 and 7. So I'm supposed to go from 3 to 2 times 3, that's 6, plus 1, 7. 3 to 7. I look at the primes, they are 3, 5, and 7. That's the answer, 3. Let's do another example. If m is 10, well, I should look from 10 to 21, 10 to 21, and the primes there are, let's see, 11 and 13, 17, 19, 4 of them, so that's why it should return 4. You cannot write code for a function whose specification you do not fully understand. So always, always, always read the spec, go through the example or examples, make sure that you can get the same answer that the example says is the right answer. That will not only make sure that you understand what the function is asking for, but typically it will show you how to calculate it, because you will have done a calculation, in this case when m is 10, to come up with 4, and the code translates to that. So keep that firmly in mind. All that said, let's run the program and see what happens. When I run it, nothing shows up. Nothing shows up. That should bother me, since we were told that the test cases are correct. So the first thing I'm going to do is see whether it even gets here. So I'm just going to print something here, doesn't really matter, and see whether it gets to broken 1. And I see it didn't print hello, so it's not even getting there. I wonder if the test case failed to call broken 1. No, it did call broken 1. In any case, we were told that the test cases are correct. I wonder if main failed to call the test cases. Aha! So that's a common error. Keep that in mind. It failed to call the run of the test cases. So I'll run again. Still no hello, nothing. Now this is one that people sometimes make that's very hard to catch. So look closely. You go all the way down to the bottom. See how main has somehow gotten pushed to be indented? That means it's part of the function definition that it's preceding. The call to main, or whatever's down there, should always be against the left edge. So if you're not seeing anything run, the code down here may have been messed up. That happens during the exam. You might want to contact your instructor and get help with that, since the code down here on the exam is a little more complicated because we do some fancy testing for you. So if nothing shows up and you've convinced yourself that the function should have printed something, that the function is being called, and that main is calling the function, but if nothing were to show up here, if we didn't see HBY, then you might get your instructor involved to make sure that the code that we supplied is calling main successfully. All right, all that said, let's go ahead and undo some of those there. So now we're getting here to the function, getting values. So I'm going to do that and run again so we have a clean slate. There we go. We expected 3, but the actual was none. When it says the actual is none, that means that the function being called, being tested in this case, does not explicitly return a value, because if the function doesn't explicitly return something, it implicitly returns the special symbol none with a capital N. So if I had not implemented this code, I'm going to temporarily get rid of it. That would be one reason why it would say none over here. And then putting it back, oops, the other reason here is that there's no return statement. So that's the first error, is there's no return statement. I'm going to give you a chance to join in here in a sec, but I wanted to show you what's going on. So now it expected 3 and got 6. I'm going to walk through the debugging process. I think what I'd like is for you just to watch this, because if you start trying to fix the code, it's pretty easy to fix because this is a simple one. What I want you to get out of this video is the process that I'm using, and that process will be valuable to you in debugging other code. The process is this. You look at the first test case that failed. Expected 3, got 6. You go up here and make your code somehow focus on that first test case. In this case, I'm going to comment out the other two. I'll select them, I'll hold down the command key, the control key, and press the slash that is beneath the question mark. That comments out that whole chunk. Repeating that action would uncomment it out. But I'm going to somehow make it so that it's only running that test, so that when I print things down here, it's going to print them only for that test. And the first thing I'm going to print down here is k, always the loop index, k, and then the number that I'm supposed to be looking at the prime of. Now remember, I'm doing the test case where m is 3. Oh, I better double check that. Let's print m is, putting some words here to distinguish it from my other prints. So I'm going to print m, make sure it really is 3. And I see that when m is 3, I'm supposed to go 3 to 7, including 3 and 7. So this second thing here should go from 3 to 7 if I've got this code right. Now, of course, it doesn't. It's probably obvious to you that it doesn't, but still, I want to show the process. So I do here, I see, oh, that second thing is stuck at 3. M is 3 like I expected, but that second thing, this thing here, which is this, this thing here, which is the same thing as this, is stuck at m. I don't want m, I want some function of k. Now I'm going to make a mistake and just put k there. In practice, you should think clearly about what you want. In practice, you should say, well, when k is 0, I want 3, so I better be adding 3 there, but I'm going to illustrate as if I didn't. 0, 1, 2. No, I wanted 3, 4, 5, etc. So I need, and I put it in both places so that my print message is matching what I'm testing. So I'm supposed to be checking the prime of 3, 4, 5, 6, and then 7. Let's see if I am. I'm checking 3, 4, 5, 6, 7. Oops, one too many. One too many. Now, the natural way to fix that is to just subtract 1 here, because it looks like you have an off by 1. In fact, we're going to see that's not the error, but I'm going to pretend that I did that anyhow. You don't need these parentheses that I just put there, but I'm going to put them there just to try to emphasize things. So now it should go 1 fewer time. It does, and it passes the test. At this point, I would now put my other tests back in. So I'm going to go up to them, hold the control key down, and press the slash that is under the question mark. That uncomments them all. I'll run again. I see that I get tons of output here. So if the output is too much, I would have, at least temporarily, commented out that print statement. I would not delete it because I'm not yet finished testing. And I would see that the first test case passes, 3, 3. The second one, when m is 10, I expected 4 and got 7. And the third test failed as well. Remember, the number of failing tests is not a good indicator of whether you're close or not close to the solution. If any test is failing, your code is wrong, period. And it's hard to say how much or little it's wrong. So don't be trying to just get more and more tests to pass. Get the first test to pass, the first failing test, and then if there are more failing tests, as here, we're going to get them to work. So we're going to take the same process. I'm going to comment out everything other than the test I want to focus on. And I'm going to put my print back in. Now before I run, I think through the problem by hand. I expect to be doing m is 10. That's the case. And I should be looking at 10, 11, 12, 10, 11, 12, up to 10 times 2, that's 20 plus 1, up to and including 21. So my k plus 3 here should be 10, 11, 12, etc. Well, it's not. It's 3, 4, 5. Oh, I don't want k plus 3. I want k plus m. Perhaps I should have seen that the previous time, but I wanted to make that error to make it plain for you. So I change in both places to k plus m. I still have errors. And I run and I see I'm starting at 10 correctly. 10, 11, 12. But I'm not going to 21 and stopping there. I'm going too many times. That means that my range statement is wrong. That this controls the number of times the loop runs. 2m minus 1 is what I've got there. Let's see, when m is 10, I'm supposed to run from 10 to 21. Well, that means taking 21, subtracting 10, that's 11 times, and maybe that's how many times I run. Oh, I have to subtract the 10, subtract the m. So I'm going to do 2m minus m. Again, I'm not there yet. I probably should be thinking more carefully here, but I want to try to illustrate what you might do. So I look at k plus m at 10, good, 11, 12, 13, 14, only goes to 19. I appear to be too short. So now I'm going to try fixing my off by 2 error. Expected 4, got 4. Okay, I think I'm closer because I noticed that it's plus m, and I fixed my range. Let's go ahead and try the other tests. So I'm going to comment out the print statement. Uncomment. I'll start with just test 1 here. Uncomment test 1. Make sure it's still passing that. 3, 3, 4, 4. Good. I'm encouraged. Uncomment my last test. Run M3. 3, 3, 4, 4, 135, 135. I'm encouraged to think that my code is probably correct. Now, it isn't necessarily correct if you pass all the tests. It just gives you some confidence it's correct. You won't have confidence if you do a lot of fiddling with your code to make it pass tests. We try to provide enough tests when we provide them that fiddling won't work, but it's hard to get that exactly right. So again, your goal is to pass all the tests. Passing all but one, for example, is not necessarily any better than failing them all. Your code is either correct or incorrect. In the final version, I don't want any prints, so I comment out that print. You can turn it in either commented out, 3344 135, or you can delete, if you wish, those prints. If it were production code, you would be deleting them, not just commenting them out. But we won't be making production code here. So there we are, passed the tests, some confidence that I've got it right, and we seem to be good. One last comment, the prints that I put were not inside the if, they were before it. It's typically not useful to put things inside the if until you've determined that you're actually looking at all the right cases. When m is 10, that it's looking at 10, 11, 12, blah, 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 21. I hope that process helped. Make sure that you follow a process like that when you're debugging. If you have any questions about this video, please, please, please talk to a student's assistant or your professor before the exam. It's too late on the exam. You're on your own for debugging on the exam. So if you have any questions about that process that I've demonstrated here, please talk with your instructor or student assistant about it before the exam.